Okay, in this lesson we looked at different applications of exponential growth and decay, or I should say exponential growth and decay models. And so we looked at this equation, y equals a naught times b to the kt. And we talked about the fact that sometimes with half-life you will also see the equation y equals a naught b to the t over k. And then reference kind of what the connection was between these two equations. Okay, so we're going to do 4 problems here for some extra practice from this lesson. Number 12, we have, if the half-life of strontium-90 is 29 years, how much strontium-90 remains after an initial sample of 23 milligrams after 38 years have passed? Okay, so since these are extra practice problems, I'm going to recommend that you pause the video, try the problem on your own, and then restart the video either when you are stuck or have an answer. And then we'll be doing, like I said, 3 others. And so maybe after watching number 12, if you did get stuck, we'll pause the video on the next one, try the next one on your own, and see if you can get a little bit further each time. Okay? So here we go. Based off that question, we are going to be looking for these values. What is our y, our a naught, our b, our k, and our t? Okay, so first things first, a naught. A naught, remember, is always your initial value, and so take a look at this example again. What was our initial value in this one? Our initial value in this one would have been 23, and so 23 is going into a naught. Whoops, 23 into a naught there. Okay, we also going to be looking at some of these other values. So for example, b is the change measurement that you are calculating. So for a lot of cases you will end up with kind of 2 measures, an initial measure and then one that was later on. So maybe you started with 15 and ended with 45, and so you'll find that your b is 45 over 15. Or you started with 12 and you ended with 36, it would be 36 over 12. Well, in this case, the nice thing about half-life is that what we're measuring is halfway. We started with one value, some value, and ended with half of that, and so our b is 1/2 because it is half-life. Okay, k is your frequency with which that half-life is happening, and so in this case, the half-life of strontium, what's the frequency that half-life is happening? In this case, it's 29 years, so it's changing once every 29 years. Or if you were to use this version, the t over k, the reason the k is in the bottom is because that's the 1 over 29. So it's just the 2 different ways that k can be written. But it's always that frequency, right? T is how much time has passed in this problem. Take a look, how much time has passed. In this problem, we have 38 years have passed. And then we are being asked to find how much strontium remains, and so in this case that means we are trying to find y. Okay, so then let's go ahead and set this up. We have y equals our a naught, our b, which is 1/2, our time, which is 38, our k, which is 1 over 29. And we can now use our calculator to plug this in, and so go ahead and pick up your calculator, take a moment, plug this value in, and you should get right about 9.274 units of strontium still remaining. Okay. Okay, so next one, we've got number 14. Number 14, we are looking at, sorry, let me slide this paper up here real quick. There we go. So number 14, we have some bone artifacts were found at the Linden Muir site in northeastern Colorado and tested for their carbon-14 content. If 25% of the original carbon-14 was still present, what is the probable age of the artifacts if the half-life of carbon-14 is 5,700 years? Okay, so go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so here we go. We're trying to identify those pieces, right? Our y, our a naught, or our initial value, our b, our K, and our T. Okay, so same thing. We want to start with here, what is my A naught? What initial sample do I have in this particular case? And they don't actually give us a measurement for our initial sample in this one. So we have some initial sample. I don't know how much. I'm going to call it, well, I'll call it I for initial. Okay. We want our B. What is the change that is happening? And again, sometimes that's two different measurements that you're going to be comparing, a second measurement over a first measurement. But again, we've got another half-life description here. And so whatever our second and our first measurement is, when I put the second over the first, we are going to get 1/2, because that second measurement will be half of the first. K is the frequency with which this measurement is happening. In this case, they tell us that this half-life happens every 5,700 years. And so my K is my 1 over 5,700. Okay? And then we've got our time element. Well, in this case, that's what they're asking me to find. What is the probable age of the artifacts? So we're trying to find time, which means they have to have somehow given me that Y, that final amount, as opposed to the prior problem. That's why I picked these two. The prior problem, we had to find that final amount. Here, they must have given us the final amount. And so then we need to take a look at this problem and go, okay, well, where in here did they give me some sort of final amount? Okay, we'll take a look at it. It's right there in your second sentence. It says if 25% of the original carbon was still present. And so however much was originally there, what we are left with is 1/4 of it, or you could say 0.25 if you wanted to, but some 25% of that initial amount. Okay, so then we're going to set this up. My Y equals my A naught B to the KT. Equation that we wrote down in our notes. And then we are going to solve. Now, unfortunately, this one's not going to be quite so basic as just plugging it into our calculator, because I do need to isolate that T. Okay, so let's go ahead and take a moment and do that. What would we need to do first? We need to undo that I. If I divide that I over, we get 1/4, because the I's would cancel, equals 1/2 to the T over 5,700. Okay. You got to figure out, okay, what am I going to do next? I need to somehow get rid of that base 1/2. Well, what's the inverse operation of base 1/2? It'd be log base 1/2. So we're going to log base 1/2 both sides to cancel those out. And so now we have our log base 1/2 of 1/4 equals T over 5,700. Okay, and then you can use your calculator to help you evaluate this if you would like, but we actually do know what log base 1/2 of 1/4 is. For the record, it is 2. Remember, with evaluating bases like that, you're asking yourself, what would the exponent need to be on my base to give me that value? And if I made my exponent 2 here, 1/2 squared would equal 1/4, which is why I know this simplifies to 2. But again, you can use your calculator to help you check that. And then what's the last thing we need to do to solve for T? We need to multiply that 5,700 over. And so we have 11,400 years is how old these artifacts must be to have 25% of their original carbon-14 still remaining. Okay. Okay, 2 more here. 2 more. Okay. Number 18 is next. In number 18 we have, in 1992, a new car was purchased for $23,995. In 1997, the Kelley Blue Book value for the car was $11,500. We're going to start by writing a yearly exponential equation to model this information, and then we're going to use that equation to figure out how much the vehicle will be worth in the year 2000. Okay? So go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so here we go. Number 18, so we're still looking for those same values. We need our Y, our A naught, our B, our K, and our T. So let's go ahead and start with our A naught. What is that initial value? In number 18, it initially started at $23,995. B, some sort of comparison measurement, right? What did we start with? What did we end with? Now this one's not half-life, so I'm not starting with some value and ending with half of that. So it's not going to be 1/2. In this case, we're starting with 23,995. We're ending with 11,500. And so this is going to be 11,500 over that 23,995. Which is going to be that comparison of growth, or in this case, decay, since the car is depreciating in value. Okay, so that's your growth or decay factor. Okay, the frequency with which this change is happening, right? In the half-life problems, it was given by how many years it takes to be halfway. In this particular case, since we established our measurements, we're looking for what's the frequency with which that change occurred. That change occurred one time in 5 years. It took 5 years for that to occur, as opposed to the 29 years for the half-life of strontium, or the 5,700 years for the half-life of carbon-14. Okay, so this is whatever this value is, not half, but 5 years to get there. Okay, and so we've got enough now for our exponential equation. Y equals my A naught, my B, to my KT. And now we're going to use that to figure out how much will that vehicle be worth in the year 2000. And so we need to figure out, well, what is this value going to be in the year 2000? So that begs the question, what are we plugging into T so I can evaluate for Y? Well, remember what we started at. We started here in 1992 at 23,995. So what are we plugging in for T? And we're plugging 8 in for T, because to get from 1992 to 2000 would be 8 years. And so if this same measure of decay kept occurring at the same rate, well then in the year 2000, which is 8 years later, that will be the value of your car. And so go ahead and pick up your calculator, plug that into your calculator, see what you get. And you should get right around $7,396.80. Okay. One more here, number 20. Okay, if you haven't already, pause the video, give this one a shot, restart it when you're ready. Number 20 talks about a macaroni penguin population. Here we go. Number 20. The macaroni penguin population doubles every year and has an initial population of 12 penguins. Write a yearly equation modeling this information. How many penguins are present 17 years later? So here we go. Those same values. Y, A naught, our B, K, and T. So A naught, the initial value. So go ahead and take a look at that problem one more time. What's the initial value? Initially we have 12 penguins. B, the growth or decay factor. Remember with our half-life, it was that the chemicals, for lack of a better word, the carbon-14 or strontium, that they were reducing by half in our car one in number 18. It was that it started at 23,000, ended at 1150, so we were 11,000, I should say, 11,500 over 23,995. So what are we in number 20? What's the growth or decay factor? In this case, is that penguin population doubles every year. Okay, the frequency with which that happens. Well, we just said it. How frequently does that doubling occur? Occurs every year. So 1 to 1, right? Once a year. As opposed to once to every 5 years for the car, once every 29 years for the strontium, once every 5,700 years for the carbon-14. This is once every year. And then last but not least, T or Y, what are we trying to solve for here? In this particular case, they tell us how many penguins, or I should say they ask us, how many penguins are present 17 years later? And so what we're trying to find is this Y 17 years later. And we've got our equation. Y equals our A naught, our B to the KT. K, by the way, it's just 1. 1 over 1 is 1, so K times 17 is still going to be 17. So then go ahead and take a moment, pick up your calculator, plug that in. How many penguins are we going to have? And then if this same trend continues to happen, that initial population of only 12 penguins 17 years later is going to be 1,572,864 penguins. Okay. And there you go.